I welcome you to the first session of mixtures and allegations. So what is alligation rule? Alligation rule is applied to questions of mixtures in arithmetic. Whenever two or more substances are mixed, then we obtain a mixture, and sometimes we have to obtain the average cost of a mixture. Sometimes we have to find out the ratio in which the substances have been mixed in order to get the average cost given. So in all these questions we are required to apply the alligation rule. For instance, when we mix two different kinds of tea to get a third variety of tea, what is the ratio in which the two varieties of tea are mixed if the average cost is fixed? So mathematically speaking, these questions are just about an extension of weighted average questions, but they are also solved by an extension of weighted average which is known as the alligation rule. And remember that any question that can be solved by alligation rule can also be solved by weighted average method. Now let us look at one of the basic situations where alligation rule might be applied. So for example, there are two varieties of tea, TA and variety B. The cost of type A tea is rupees 12 per kg and the cost of type B tea is rupees 20 per kg. We mix these two varieties to obtain a third variety, and the cost of the third variety is rupees 15 per kg. In what ratio should we mix these two types of tea, TA and TB, so as to obtain the variety C, which costs rupees 15 per kg, and the cost of type A and type B tea are given. So this is a classic situation where alligation rule can be applied. So first and foremost, before we jump into alligation rule, I've already told you that anything that can be solved by alligation rule can also be solved by the weighted average method. So the first thing I will do is I will explain how to solve this question by the weighted average method. So TA and TB, rupees 12 per kg is the cost of TA, rupees 20 per kg is the cost of TB, and the cost of type CT is rupees 15 per kg. So let us assume that the quantity of type AT is X kg and the quantity of type BT is Y kg. The average cost is defined as the total cost of purchasing type A and type BT. So total cost divided by the total quantity, which in this case will be X plus Y. What is the total cost? The total cost is cost of purchasing type AT, that is 12 multiplied by X here, plus 20 into Y, that is the cost of purchasing type BT. This is the total cost of purchase. And what is the total quantity? That is equal to quantity of type AT, X, plus quantity of type BT, that is Y. So we calculate 15, which is given as the average cost, is equal to 12X plus 20Y divided by X plus Y. On simplifying this, we get 15x plus 15y is equal to 12x plus 20y, and therefore 3x is equal to 5y, and the ratio of x upon y is 5 as to 3 or 5 upon 3. So we can answer the question by applying weighted average, and we can say that the ratio in which type AT and type BT can be mixed or should be mixed is 5 as to 3. So now let us apply the same concept to the case of sale of two items, and we have item A and item B. There is a 12% profit earned on item A and there is a 20% profit earned on item B. And overall the total profit earned is 15%. We've got to find the ratio of prices of item A and item B. Apparently speaking, this question is different. But again, this question can be very easily solved by applying weighted average. Let us see how. So if we assume that the price of item A is X rupees and the cost price of item B is Y rupees, then the average profit must be equal to total profit in rupees divided by the total cost. This will give us the average profit. How do you calculate the total profit? Total profit is profit on the sale of A, that is 12% of X. So that is represented as 12X here. And the total profit on sale of Y, that is 20% of Y, which is represented here as 20Y. And what is the total cost? The total cost is again X plus Y. So average profit is given as 15 is equal to 15% is the average profit given to us. So 15 is equal to 12x plus 20y upon x plus y. On simplifying this, we will get 15x plus 15y is equal to 12x plus 20y. 3x is equal to 5y, or the ratio of x upon y is 5:3. Therefore, the ratio of price of item A and item B is 5:3. Let us see another situation where we can apply alligation rule, and we solve questions in that situation also by weighted average first. So mixing of two solutions of lemon juice. Let us say we have solution A and solution B. Solution A is 12% lemon juice, while solution B is 20% lemon juice. When we mix these two solutions, solution A and B, we obtain a third variety of solution whose lemon percentage is 15%. We've got to find the ratio of quantities in which solution A and solution B is mixed. Again, if we assume that there is X units of solution A and Y units of solution B, then the average strength of the solution also implies the average percentage of lemon in the solution. It is given by the total quantity of pure lemon in the solution divided by the total quantity of the solution. Now, how do you calculate the quantity of pure lemon? For example, this is 12% lemon. So if there are X units of A, then 12% of X must be pure lemon. So what is the total quantity of pure lemon? Total quantity of pure lemon must be pure lemon from solution A, that is 12% of X, plus quantity of pure lemon from solution B, that is 20% of Y, represented as 12x plus 20y. And what is the total quantity? This is equal to x plus y. So average strength is already known to us, 15%. This is equal to 12x plus 20y upon x plus y. On simplifying this, we get 15x plus 15y is equal to 12x plus 20y, and 3x is equal to 5y. So what is the ratio of x upon y? The ratio of x upon y is 5/3. This is the ratio in which solution A and solution B must be mixed. So what do we see every time in the last 3-4 questions? We saw that we could apply weighted average to each one of the previous 3-4 questions. Now let us look at another type of question where weighted average as well as the alligation rule both can apply. Let us say there are two alloys containing gold and silver. We have alloy A and we have alloy B. Alloy A has gold and silver in the ratio of 5:4. This time it is not given in percentage but given in terms of ratios. Similarly, alloy B has gold in the ratio of 1:5. Some quantities of both alloys are taken and mixed to give rise to a third alloy where the ratio of gold and silver is 1:1. So we've got to find the ratio of quantities of alloy A and alloy B. Let us assume that we take x kg of alloy A and y kg of alloy B. So in x kg of alloy A, 5/5 plus 4, that is 5/9 x quantity of gold should be present. Similarly in alloy B, 1/1 plus 5, that is 1/6 of y amount of gold should be present. So how do you define average gold? Average gold is total amount of gold from alloy A plus total amount of gold from alloy B divided by the total quantity. So what is the total amount of gold from alloy A? 5/9 into x. So this is the ratio of gold and silver is 5:4. So 5/9 into x. Plus the ratio of gold and silver here is 1:5. So 1/6 into y. This is the amount of gold from alloy A and alloy B. What is the total quantity? The total quantity is x plus y. Now on substituting these values, we get the average quantity of gold, which is 1 by 2, because overall the ratio of gold and silver is 1:1. Therefore, the fraction of gold in the final mixture must be 1 by 2, 1 upon 1 plus 1, is equal to 5 by 9x plus 1 by 6y upon x plus y. And if you simplify this, you get 1 by 2x plus 1 by 2y is equal to 5 by 9x plus 1 by 6y, and which means 1 by 18x is equal to 1 by 3y, and hence x upon y is equal to 1 upon 6. So with this we come to an end of this first session of mixtures and alligation. In the next session we will take a look at how to solve such questions by alligation rule, which is a much simpler method of solving these questions. In case you have any feedback or any query regarding this session, feel free to contact us at studentservices@pfindia.com. Thank you.